So how would we actually answer this question then? So I would be looking back at figure 5 and I would be starting to think about some of the rules that we know about electron configurations. So one of the main things that you get taught when you're doing electron configurations is how many electrons you can fit in each shell. So in your first shell, you can only fit 2 electrons. As you can see, both of these have got full first shells. Makes sense because you can't put anything on the second shell until the first shell is full. So they've both got 2 electrons in the first shell. After that, in the second shell, you can fit 8 electrons, and in the third shell, you can also fit 8 electrons. The other thing you need to be aware of is atoms are going to try to form full outer shells. So they don't necessarily stay atoms, they become something called ions. They try to get these full outer shells, and that's just because they're a lot more stable like that. So if we look at calcium here on the left-hand side, what you can see is calcium's got 2 options, basically, on how it can achieve a full outer shell. I would say that energetically, the most favourable way that calcium is going to gain a full outer shell would be to lose this electron here and this electron here. And if it loses both of those, that means that it drops down in energy level to this electron shell here. And that is full because that's got 8 electrons in it. That's the maximum we can fit in the third shell, and therefore that is now more stable. So it will lose these 2 electrons. However, keep in your head those 2 electrons because they can't just disappear. So what we would see would be it dropping down to that third shell, and that third shell would now be full. Oxygen, on the other hand, is in a slightly different situation. So oxygen has got 1, 2, 3, 4, 5, 6 electrons in its outer shell. It can fit 8. So this is in sort of an equal but opposite situation. I would say that for oxygen, it's easier for the oxygen to gain 2 electrons. If it gains 2 electrons, it'll then have 8 in its second shell, and that is also a full outer shell. But where on earth can it get these 2 electrons from? Well, it's going to take the ones that calcium has just given up. And that's how those 2 things work together in order to start to form this ionic bond. However, the ionic bond is not just about these sharing electrons or giving electrons from the metal to the non-metal. It's about the formation of a charge from this. And this is something else that was also commonly not answered all that well. So you should know from your previous modules, so particularly C3, which is your atomic structure, that electrons have got a negative charge on them. So if calcium is losing 2 negative charges, it's going to form a +2 charge. Just like if I said to you guys, lose a little bit of negativity, I would expect you guys to become a little bit more positive. And it's exactly the same thing here. It's lost not 1 negative, but 2 negatives, and therefore it would form a 2+ charge. Oxygen, on the other hand, has gained 2 negatives, so that would form a 2- charge. And it's the attraction between those 2 charges, because opposites attract. It's the attraction between those 2 that forms this ionic bond, and that is what we call electrostatic attraction. So with that in mind, let's have a quick little look at the examiner report. So it's this question 2 here. So just as I said before, many good responses, although not very many people got all 3 marks. So some candidates lost marks for not following the instructions about dots and crosses. So if you were to obviously redraw these diagrams up here, we have said that we are moving 2 electrons from calcium over to oxygen. They should remain as dots. They should not become crosses because they're now on oxygen. They should remain as dots so that we can see that they have came from the calcium. So that was one really, really key point. Another one was that others simply repeated the dot and cross diagrams that had already been given. As I've said, you would never be asked to just repeat information, so I like to think we won't get that one wrong. The other one was just that they drew the wrong charges. So remember, if you lose in a negative charge, you become positive, and if you gain in a negative charge, you become negative. Okay, so there's actually a nice way to remember it. Metals will always become positive and non-metals will always become negative. So you can even write non-metal with a little dash in between, and that dash can remind you about it being a negative charge. So this also said a lot of people managed to transfer 2 electrons over, but not everyone managed to transfer both of these electrons. Some people just transferred 1 electron, whereas it obviously should be 2, because if it loses just the 1 electron, it still leaves 1 in the outer shell. It's still unstable for calcium. It does say not many people transferred the wrong way, so that's pretty good. All quite happy with that. Something else here, though, that you can see, this one looks almost perfect. We've got the dots from the calcium drawn in the correct way. We've got all crosses on the oxygen. However, there is one problem here, and that is, I'll show you just on this diagram, we've lost a full shell of electrons from the calcium. So what you can see is on this figure 5, we've got 1, 2, 3, 4 shells of electrons, or 4 shells that have electrons in them. They've almost tried to trick you a little bit in this question by only giving you 1, 2. So then some people will have transferred these electrons over from the 4th shell and then forgotten to fill this 3rd shell. But actually, you can't lose 10 electrons all in one go like that. So these 3rd shell electrons, there's 8 of them, should have also been drawn in. So that's what that bit's saying, that this was a really, really, really common mistake. So people did all of the transferring correct, they did the charges correct, but they forgot about this 3rd shell, because actually, if this was the case, which it wouldn't be, but if it was, then it wouldn't be a 2 plus charge, it would be a 10 plus charge, because you actually lost 10 electrons. So just be really, really careful with that one too. And then we've got another answer here, and this one is just showing how some people have just absolutely copied the diagram, so just make sure we're not doing that. Okay? The last thing I just wanted to highlight here for this question, and this does link a little bit to your C3 and C4 modules, but it was this question here. So the second part of this periodic table question. So what this is saying is it's giving you a periodic table, it's giving you some different letters. The letters are not the symbols from the periodic table, it's just some random letters. First part says, using these letters, you need to answer these questions. So first things first, if it's saying use these letters, don't be trying to replace these letters with element letters or element symbols. It wants you to use these letters. You need to use these letters. And the second part says, so this is the one that I want to focus on, give the letters of 2 elements in period 2. So you guys need to know your groups and periods, because it makes you drawing electron configurations and all of that a lot easier. I'm not going to go into that because that's for a different video. But you guys need to know what each group is and where each period is. And this, in the examiner report, apparently hardly anybody got this question right, and I just really wanted to highlight that. So the elements that are in period 1 are actually in this row here. So that would actually only be hydrogen and helium. And then period 2 starts here from where it says A. So I'm going to do what I've just told you not to do, but that would be lithium on your periodic table. And everything that goes across from lithium all the way across here is period 2. And then period 3 would start where this J is. Okay, one of the most common things that people get wrong is they forget about this hydrogen and helium being period 1. I think just because hydrogen is not right in the very top left-hand corner, people tend to forget about that. But it's really, really important that you know that one. Okay, so I'll just show you what that says. It was just for this one. This question was very poorly answered on the whole, with most responses not even scoring the 1 mark. And that was just because the main misconception was about people not being sure about the periods. So you just need to make sure that you remember period 1 is hydrogen and helium here. Period 2 starts here with the A, or what would be lithium. I hope that was helpful. Thank you very much.